Hello students, welcome to third session of Basic Concepts of Metallurgy. We studied about crushing and concentration in detail in earlier video. If you have not watched it, please find the link given below in the description. In this video, we will study third step of metallurgical operation, that is reduction. Hope all of you have understood the first two steps involved in metallurgical operation. In the first step, that is crushing, we obtain powdered ore. In the second step, that is concentration, impurities are removed from the ore and the ore is converted into its oxide. In the third step, that is reduction, oxide ore is reduced to its metallic state. In this video, we shall study about reduction in detail. Reduction of metal oxide means removal of oxygen to obtain metal in its free state. This is done with the help of reducing agents such as carbon, carbon monoxide, aluminium, etc. There are three different ways of reduction: smelting, alumino-thermic reduction and electrolytic reduction. Let us study one by one all of them. First, let us study about smelting. Smelting is the reduction of a metal oxide with carbon at high temperature. We can also use compounds of carbon like carbon monoxide, carbon dioxide, etc. In practice, the calcined or roasted ore is mixed with coke and flux. Here, coke acts as a reducing agent and flux removes the impurities in the form of slag. The mixture is then heated in a blast furnace or reverberatory furnace in presence of controlled air supply. Blast furnace is used for reduction of iron oxide, while tin oxide is reduced in reverberatory furnace. The reducing agent, coke, converts the ore into molten metal. The flux removes the gangue in the form of fusible mass, which is known as slag. It is important to remember that coke acts as a reducing agent as well as a fuel during smelting. We have studied the construction of reverberatory furnace in earlier video. Now we will study construction of blast furnace. It is a combustion type furnace. Blast furnace is a combustion type furnace. It is a tall cylindrical furnace about 20 to 30 meters in height. Its width is about 4 to 8 meters. It is made up of fire clay refractory bricks. It has an outer shell made up of steel plate. Upper part of the blast furnace is known as throat. The middle part of it is known as the body. Okay, this is the body of the blast furnace. Lower portion of the furnace is known as hearth. Between body and hearth there is bosch. Okay, between body and hearth there is bosch. Therefore, a blast furnace contains four important parts. One is the throat, other one is known as the body, other one is known as the bosch, and finally it is the hearth of the furnace. The mouth of the furnace is closed by means of cup and cone arrangement. Observe the figure carefully. This is the cup and cone arrangement. One of them being closed when the other is opened. Thus prevents the escape of furnace gases. The furnace increases in diameter from the throat downwards until it has attained maximum diameter at the bosch. This is a portion of the blast furnace where the diameter is maximum. From the bosch downwards, diameter of furnace contracts rapidly up to tires. This is a portion of the blast furnace where its diameter is minimum and then it becomes nearly cylindrical. It retains this form up to the bottom. About 2.5 meters above the base of the furnace, there are series of tubes called tires. Okay, about 2.5 meters above the base of the furnace, there are series of tubes and these tubes are known as tires. Hot air is blown through these tires into the furnace. At the bottom of the furnace, there are two outlets. One is the upper outlet, other one is the lower outlet. With the help of the upper outlet, we remove the slag from the blast furnace. With the help of the lower outlet, we remove the molten iron from the blast furnace. There is an exit for waste gases at the top of the furnace. Okay, observe here. This is an exit which is present for the exit of waste gases. Important functions of blast furnace are as follows. It reduces the ore to metallic state. It removes the impurities in the form of slag. That completes the construction of blast furnace. Next, let us study about alumino-thermic process. This is also known as thermite process. In this process, aluminium powder is used as a reducing agent. Stable oxides like chromium oxide, manganese oxide, etc. are not easily reduced by carbon. In such cases, aluminium is used as a reducing agent at higher temperature. A mixture of aluminium powder and metal oxide in the ratio 1:3 is taken in a steel crucible placed in a sand bath. Mixture of aluminium powder and metal oxide in the ratio 1:3 is known as thermite. A mixture of aluminium powder and barium peroxide is placed over the thermite in the form of a heat. Magnesium wire is embedded in this heat and the other end remains free outside the crucible. This magnesium wire is lighted. It starts burning and in turn causes the burning of a heap of aluminium powder and barium peroxide. Due to this burning, a large amount of heat is produced and temperature increases. This raised temperature helps aluminium powder to reduce metallic oxide into metal. This reaction is highly exothermic, that is, heat is liberated during the process. Reaction 1 started go on until all the metal oxide is converted to metal. Observe these chemical reactions. When chromium oxide is heated with aluminium, it gets reduced to chromium. When manganese oxide is heated with aluminium, it gets reduced to manganese. When iron oxide is heated with aluminium, it gets reduced to iron. Chromium and manganese needed for special alloy steels are prepared by this method. This reduction property of aluminium is used in thermite welding for joining the broken pieces of heavy iron objects like railway tracks or cracked machine parts. Lastly, we study electrolytic reduction. In electrolytic reduction, reduction is carried out by electrolysis. All of us know electrolysis involves chemical decomposition of an electrolyte by the passage of electric current. Highly electropositive metals like potassium, sodium, magnesium, aluminium, calcium, etc. are extracted by electrolysis. Electrolysis of oxide, hydroxides or chlorides of a metal in fused state yield the corresponding metal. The metal deposits on cathode during the electrolysis. For example, sodium metal is obtained by electrolysis of fused NaCl. Observe the figure. Sodium chloride in fused state contains sodium ions and the chloride ion. During electrolysis, these ions under the influence of electric current travel towards oppositively charged electrode. Thus, sodium ion move towards the cathode and finally we get the deposition of sodium on cathode. Chloride ions move towards the anode and finally we get chlorine gas along the anode. Observe the chemical reaction. Fused NaCl dissociates to give sodium ion and chloride ions. During electrolysis, sodium ions will move towards the cathode. This positively charged sodium ion will gain one electron and gets discharged as sodium atom. Chloride ions will move towards the anode as they are negatively charged. These chloride ions will lose the electrons and get converted into neutral chlorine atom. Two chlorine atoms combine and hence chlorine gas is liberated along the anode. In this way, we can obtain the metal along the cathode by electrolytic reduction. We have studied the different methods of reduction in this video. Answer these multiple choice questions to test your understanding. See you guys again in the next session. Thank you.